what's up, everybody? Jason here from Unity3D.College, and I've got Charles Amat with me. He's a software developer, game blogger, game YouTuber, talks about video game development, and teaches people how to do test-driven development and a whole bunch of other stuff in Unity. Today, we're going to talk about mostly TDD, test-driven and behavior-driven development in Unity, and then maybe go into some play mode testing stuff near the end. So before we go too much further, I just want to say hi, Charles, and thanks for coming on. Really appreciate it.
Me. Appreciate it.
Should be a lot of fun. We met up at Unite just a couple months ago. We got to hang out, and it was a lot of fun just hanging out with other people who are doing the same kind of thing and interested in the same kind of subjects. We were talking a little bit before this, and you mentioned you're interested in things like design patterns and just, I think, code architecture and getting clean code. And so I thought it was a really great fit to just have you on and just talk about these kind of things. So do you want to say anything before we get going?
Well, for those of you who don't know me, I have a YouTube channel, infalliblecode.com, or Infallible Code is the YouTube channel, and my website's infalliblecode.com. I'm a software developer by day and Unity developer / game developer hobbyist at night.
Cool. Yeah, and we'll have a link to the YouTube channel in the description and notes and stuff. Everybody can go check it out. It's a great channel. Definitely recommend you subscribe and check it out. I was curious. I didn't mention this before, but I was wondering what got you into Unity development. So I know you do a lot of other stuff that's non-Unity stuff. So where'd you start there?
Well, programming has always been a passion for me, and I spent a lot of my time, trying to understand design patterns and processes and just anything related to programming. And a couple years ago, I was trying to create a chat bot. And I played around with like a real low level console based one, but I wanted to give it a UI. I really wanted to get the whole experience of developing a nice little application from scratch. And so I researched a couple different frameworks and things like that and came across Unity, and I figured, well, it's for game development, but I could still get what I want out of it using it. So picked it up, spent a couple days tinkering with it, and really honestly never had any intentions of doing game development. Just wanted to get a chat client with a UI. And I just fell in love. I mean, I've always had a bit of a creative side to me. So it served as a real nice creative outlet that allowed me to take what skills I was trying to develop in programming and combine that with what skills I had and was trying to now develop in my creative side. So that's how I kind of got into it.
Oh, that's pretty cool. It sounds like it worked out then, or were you able to finish the chatbot and did it all work?
Yeah, it definitely did. I mean, it wasn't robust and it had errors, but we had it in my office and my coworkers were all chatting for a couple of days with it. And then, I think we actually implemented a message of the day, and that was it. I just started going from there and just seeing what else I could do.
Oh, cool.
Yeah.
It sounds like a lot of fun. And an interesting way to kind of get into Unity. I've known a lot of people who got started with Unity through just non-game projects, contracts that they had to do and stuff. And then, and it had the same situation where they fell in love with it and started realizing that they could also just make games. Because I think a lot of people think that making games is some kind of magic or something harder than normal software development. There's some parts that are harder, but there are some parts of all software development that's hard, Building AWS is hard, just like building, Assassin's Creed is hard. But that's not everything that in software or everything in games. That's funny.
That's kind of why I got into software development years ago was, I did kind of want to unveil the magic behind. Well, I mean, back then, like on MySpace, I would look at that and I would try to pull up the source code, and I would think, wow, look at all this. Like, look at all this. What is this? What am I looking at here? How do you make this web page where I can add friends? And it fascinated me. And I got my start in software development with the same way I kind of got my start in Unity. I just was so curious about pulling back the covers and trying to create something and seeing how it's done.
And that's awesome. I think that's the best way to go. It's because you got that self-drive and that motivation to want to figure things out and discover stuff and then learn it and use it, which I think is a blast. And that's pretty much how I learned software stuff too. Well, mine was like, I had 3 games and I wanted more. I didn't have any money and I was a kid. So I was like, make
make
my
your
own.
own.
I did a terrible job, but I tried and failed a bunch, and it was fun.
That's the best way to grow
I
is
found
through
out that it was
failure.
just as much fun. It's like a game writing your own game.
Oh yeah,
So,
for sure.
I was curious, when you made the switch into Unity, you were coming from, it was mostly a JavaScript background, right? Or was it
Java.
some Java? Okay, Java
Yeah.
background. So how did you find that transition into doing Unity development, that kind of that bridge, that, jumping into another language, another framework and environment, and all that?
Honestly, it was very easy for me mostly because C# and Java, especially back when I had gotten into Unity, were very similar when in syntax. And even today, a lot of the features that are being developed for C# are in Java. And my day to day, I'm not a game developer by trade. I'm a software developer, and I deal a lot with this language called Groovy, which has a lot of syntactic sugar. And it's funny to me that C# is developing towards a lot of the features that Groovy has, with all the syntactic sugar. So all that combined, it was very simple for me to really get into the C#, the programming side of Unity. Now, the actual being a power user of Unity, that was obviously a little more challenging. I'm sure everyone's tried to mess with like the Mechanim animator trying to create sophisticated animations, and you're just there like, oh my God, how do I make all these states work, and substates and nested states? And back in the day, trying to do things like nested prefabs and thinking like, what, this isn't possible. So that was the more difficult side of it. And also the artistic side too. Like, I would just try to go online and find sprites, but then I went through this, I swear, like a 1.5 year long phase where I was like determined to learn Blender and to become like a 3D modeler before I realized that people make careers out of this. What am I doing trying to thinking I could just make all my own models. But
Like when
the
your
code
artist
side
decides to make their own code.
no, exactly. Not to say that it's not possible, but you got to compromise a little bit and understand that you're not exactly going to be, the best at it. So
very few people are really good at both.
Yeah.
Right? At art and code, or art, code, and design. It's really rare that I find somebody who's good at all three of those, like exceptionally good. Yeah.
I think what's important though, for the artist who learns programming and for the programmer trying to learn how to make models, is as long as you can delve into each, aspect of game development, even like audio is a section that I've only recently started getting into. You can at least understand the language of each of these particular, trades, if you will, or skill sets. And in that way, being a game developer, you have to be a jack of all trades in some sense. And that way you could talk to others. And if you were to, solicit the help of other people, or even hire other people in different, trades, you could at least speak their language. At least if I ever needed to hire a modeler, I could, I understand a little bit of what I'm talking about. And I know a little bit about what I can request and what to expect. So I think that's a good part of at least trying everything.
Yeah, and it helps a lot when you're on a team too, and you're working with the artists to be able to communicate with them and help them with technical issues related to art, or art getting into the game, stuff like that. It's definitely it's a good skill set, and not something that everybody has for sure. So I think it's really valuable.
It's worthwhile.
Definitely. So I wanted to ask, I guess, on the unit testing, for unit testing, how did you get started with it in Unity? Was it like when you started up Unity, you were already doing test-driven development on your day job, and you just wanted to go, hey, let's do test-driven development here? Or was it just something you stumbled into, or how did that start?
Well, when I first got into Unity, and really just doing any sort of game development, you sort of just hack things together, but eventually, me being a software developer and also being kind of a control freak, I am really particular about, my workflows, how I code, understanding design patterns and applying that. And unit testing has always been really important to me. So, it's only natural that the more I used Unity and the more I actually got serious about developing games and developing whatever sort of tools I needed using Unity, that I was going to need to know how to test with Unity. So from pretty close to the beginning, I would write some pretty rudimentary tests. And test-driven development obviously naturally just kind of followed that. So yeah, it was pretty much that. It was just, you know what, if I'm going to be working in Unity and if I'm going to treat this as something that I'm seriously considering doing and I'm seriously doing, then I'm going to do it right. And I'm going to respect the process. And testing is, to me, is an integral part of the software development. So, you know, it's natural that I would do that, you know?
Right. Okay. I mean, I think it makes sense. That's kind of what happened for me too. I was, took some time doing non-game stuff. There was a lot of TDD out there, not everywhere, but there was a lot, and the best non-game software developers that I knew were all doing TDD and BDD stuff. So I thought I should probably try to start implementing this in my non-game projects that I was doing at first, and then it just kind of bled into my game development projects as well. And now I feel like it's extremely important, which one of the reasons I think we're talking, right? Like, it's a really good subject. But I guess for people listening who don't know what TDD is, would you be okay with giving them just a real quick description of like how you would describe TDD to a new software developer who's just kind of getting started and maybe knows how to make a little Flappy Bird game, but not much more, or maybe they're somewhere in the middle. I don't know.
Sure. Yeah. So TDD stands for test-driven development, and it's a software development style. So it's really just a process of writing code. Now, I could open up Notepad++ and punch out the same code I would punch out using TDD, but the way that you write code when you're using the test-driven development process is that you're iteratively writing tests as you go. And there's this 3 steps where you write a failing test, you make it pass in the most simple way possible, and that typically includes just hard coding values, return values, and then you refactor the code in order to match the final algorithm. And it's a really kind of like an emergent sort of style of developing, because as you're writing these tests, an algorithm typically gets teased out, as they say. So it's basically that development process. And there's a lot of different development processes. And TDD, the common misconception is that if you learn TDD and you say that you do TDD, that's all you do, which that's not true. I don't TDD 100% of my code. I would say I use TDD to develop in my day job, maybe 30% of my code. And sometimes in Unity, even less than that. But it's really a very good practice to have and keep and to understand how to do, because it serves a lot of purposes. It can motivate you to write code that seems daunting. It could help you stay focused on code that is difficult or more complex, something that might take you a long time to write. In doing the TDD process, you have this assurance that even though, weeks ago you were working on this portion and now you're working on this portion, you still have the confidence in what you wrote months ago, which I know is something that I've definitely felt, having a lack of confidence in old code that I wrote months ago. And on top of all that, it helps you develop a test suite, which in the long run is very useful for ensuring that your code runs and doesn't break in production.
Sounds like you kind of hit all of the benefits there that I can think of, and the ones that I've been seeing, except for speed too. The other benefit I've had from it is just that with some projects, it makes it faster to develop. Projects where I have a long startup time, like the one I've been talked about recently is an MMO project where it's multiple minutes to start stuff up. So if I make a little change, it's a whole lot easier or quicker to test that with a TDD-driven approach. Or
definitely.
TDD approach, because that would be driven twice. Test-driven, development-driven. But yeah. So when you're writing these tests, how do you write them? So you're in Unity, you've got your code editor open, whatever it is, Visual Studio, Writer, hopefully not Mono Develops instead, or maybe VS Code.
I'm all Vim, baby.
So you're in I'm sorry. You're in whatever editor you like, and you're writing your Unity code. How do you start writing a unit test? Like, how does that? What's that process?
It depends. I mean, another misconception of TDD is that you're supposed to just open up your editor and start writing, which can happen. But a lot of the time I've already whiteboarded or thought through or written down kind of my at least high level inclination of what the code's going to look like. I at least understand the interface that I'm going to be programming. The interface being, you create a class, the public methods and properties are the things that you expect some other part of your code to utilize. So if I'm developing some sort of algorithm, the first thing I think of is how is it that I want to interface with this algorithm? How do I want to, I'm trying to think of a good example.
Yeah, is there like a simple example, like a game? I'm trying to think of a good gameplay example that we could.
Well, I did a whole series on test-driven development, and the example that I used was a health container.
Yeah, let's do that. I think that's a good example. I remember watching those videos.
Yeah, so if you think of a health container, I think I created a class. I called it Gauge because after I merged the design, I figured that a health container could be like a mana container, could be like a potion container. It's really just a gauge that holds some value. So I thought about that. I whiteboarded that, kind of worked through genericizing it a little bit. But then I thought, well, how am I going to increase the value, the contents of the gauge? Well, I'm going to have some public method called add, or fill, I think is what I called it. Want to fill the gauge. So I'm trying to think of the language I'd use, something to make it very easy for someone looking at the code to read, gauge.fill. What does that mean? Okay. So at that point, I would not have a class. I would not have any methods. I would just have a blank test and I'd give it a name. And I would start with a base case. The base case would be when I add 0 to the health gauge and the health gauge is at 0, then it should have 0.
So this would be the first test would be.
Yeah, the first test would be
a base 0, the health is at 0. And you do these tests in a separate file, right?
Separate file.
Right. Test file and then a public method with the test attribute on it with the square brackets around it. And then you automatically add the using NUnit statement.
Exactly.
Right? And then
depending on which unit testing framework you're using, typically people would use NUnit. It's one of the more popular ones. There's some other really nice ones that have like a nice fluent interface, but yeah, NUnit. So yeah, you basically mark it as a test method and you give it a relevant name. And the name, you'd want it to be something that you could read it and understand immediately what it's testing. With tests, you want to be as discreet as possible so that when they do fail, and the idea is that maybe your test will eventually fail and they'll help you, you'll be able to look at the one test and say, okay, I know exactly what failed. I know exactly where to go in the code to fix the potential bug, the regression. Yeah. So, for that test, I would say when I add 0 to an empty test gauge, or to an empty gauge, the gauge is empty. And at that point, I would try to figure out, okay, how do I create a gauge? So I'd maybe have a local variable, call it gauge, equal new gauge. And that's the new class. At this point, I haven't created the gauge class yet. So I'd get compilation errors, it'd be failing. And then I just write out the rest of the test. I would say gauge.fill, pass in 0. And then I do an assertion, assert that gauge.value equals 0, just very simple. Okay. At that point, all the code would be failing, and that's part of the test-driven development cycle. To make it pass, I would write all of the code, the auxiliary code needed to make the test pass, which is I would need to create a gauge class. I would need to expose a public method called fill that takes an int value or a float value, and then I would need to expose a property named value. And at that point, the test would pass because I'd return 0. And that'd be it. And then I just honestly go from there. And it's funny, if you're hearing about this for the first time, it probably sounds absolutely ridiculous. Like what are you doing? Just write the gauge class. Yeah, no, for real. But hey, 6 months later, when I'm adding more detail to this gauge class, more sophisticated behavior, I'm going to want to rely on these very simple tests to make sure that I'm not introducing regressions. And that's something that I think people kind of overlook with test-driven development, and honestly, just testing in general, that you're trying to protect yourself from regression. And a regression is when you add some modification to your code that affects another area of your code that you weren't even working on.
And breaks it.
Yeah. Regressions are very common, and they really have the ability to stop you in your tracks on a project, especially games. Games are very complicated, and
They will kill your ship time, your ship date, your release dates. They'll slip constantly if you're continuously introducing new bugs and constantly having to fix and build and retest over and over. It's really, really bad. So it goes a long, long way. And I mean, with your example is great for like how you would get started and start the actual testing. But when you get into your actual big project, you're testing all kinds of things. You're testing that things are dying right, that things are taking the right damage from this specific type of weapon in this specific place or whatever. And then immediately with your regression test, like you said, you just automatically kind of, we'll talk about how you run these, but you run the test and then you know what broke. And like you said, if your tests are good, which I think we probably elaborate on, you'll know exactly where the issue is.
Yeah.
Like in your health test, you'd obviously know like it's the health because that's the only thing that you're doing, which I think is kind of one of the important things to talk about. Just how many things do you normally test in a unit test, Charles?
Well, in a single unit test?
Yeah.
One thing. One assert, single asserts. You don't want to test more than one thing in a single test because the idea is that in a perfect world, and obviously there are compromises, and this doesn't, there are edge cases, but in a perfect world, each test should only have one reason to break. And if a bug is introduced, it should only break one test. Of course, this isn't always, we don't live in a perfect world. So obviously you're going to have some sort of tests that have a little bit of a crossover. But yeah, that's the idea. You just one assert per test.
Yeah, it makes a big difference on telling what's wrong. I think just having just that one thing there. But I have to also confess I do have some tests that test like this thing switched to this state, and then I did the thing again and it went to the next state. Like it went from like this to this to this. And it's you can expect the thing like I added the buff, it added the thing, and then I removed it and it removed it, went back down. Like
hey, at least you're testing, which that's a good start. But you can kind of think of that as a system level test or an integration test or a functional test.
Yeah,
there's different granularities,
right,
of tests.
I think of them as bad tests that I should probably fix. I'm confessing to having right now that need to be refactored.
You're being
that's
honest.
The thing. I try to refactor them a bit on as I get better at it too. This is cool stuff, man. Unit testing has really changed my entire workflow. Like I said, I think when we were talking earlier, I just test everything now, or not everything. I test everything that's in a real project that's going to last and be around for more than a year or be seen by other people and actually matters. Like throwaway stuff, little projects, samples, my own stuff that I don't know if I'll ever finish. I don't test any of that.
Prototypes.
Yeah, exactly. Big projects where there's interdependency and stuff could break, or other people are going to be using it. The tests are vital. I think they make a huge difference.
Yeah, that's the thing too. I mean, at the point that you're considering writing unit tests, I mean, you got to figure you've already laid out the features you're about to develop. You've already laid out, if you do agile development, you've already got a sprint planned. You know where you're headed. You've got together and you've either on your own whiteboarded or you've taken notes. You've decided how you're going to code this thing that you're going to create. And at that point, tests are simple. I mean, to me, it's like, at work we do sprints and we do the Scrum methodology. And for every ticket we write, for the most part, we'll have a user story and we'll have acceptance criteria. And when you read the acceptance criteria, it's obvious what you need to be testing for the most part. And I even mean the granularity of the test. You have unit tests, which that's when you're really writing lower level code, but eventually, especially in game development, you're going to be writing something like a UI, like clicking here, dragging a potion there. And at that level, you're writing functional tests, and that's at a way more higher resolution, or rather lower resolution. That you have to test that as well. So you're testing at all levels, and it's obvious once you plan it out. Now, the thing about game development that I think a lot of people are adverse to testing is that typically when someone, I mean, maybe this is kind of a really broad statement, but I would think that a lot of people open up Unity and they have a vague idea of what they want to do, because it's fun to kind of just tinker around, throw a prototype together. And the code that you're writing is almost reactive. It's like, maybe you have a sprite, maybe you have a model with some animations and you're thinking, oh, I want to make it jump. I want to make him jump and climb and grab this ledge. So you open up Visual Studio and you're like, okay, how do I do this? And then you go into Unity documentation. You say, well, I guess I can do a ray cast here and see if he's close to the wall. And at that point, maybe I'll lock his X and Y, and then you just kind of slam it out. But I think when people are on a serious project and they've discussed it and they've planned it, and the whole grabbing and jumping and climbing feature is a part of a long list of features that are part of your sprint, you're operating at a different level where testing is just obvious.
Yeah, it takes the issue I've seen, and I think, is that it takes some relatively good separated code to be testable too. Yeah. And a lot of games, or I guess a lot of developers in general, not just game developers, just developers in general, don't know how to do those things yet. Like, they just haven't seen them or haven't seen the value of them. So they tend to have, a lot of bigger monolithic classes, or lots of tight coupling between things. And it makes the testing really hard. Mm-hmm. I guess I know kind of my favorite patterns, but what would be some of your favorite patterns for making your code like testable, or what would you recommend for people to do to make their code more testable so that they can write these unit tests and not have all their stuff break and fail to
I would say in Unity, the number one pattern you could for testing is probably the humble object pattern. And the humble object pattern is simply an encapsulation of the logic that's being run by your mono behaviors. So the idea there is that, and you can test mono behaviors directly. It just requires, sometimes it requires you having to do these play mode tests, which we talked about, we're going to get into, where you're actually depending on the entire ecosystem of Unity to be running, to allow these update methods, start, awake, all the Unity event methods, they have to be triggered by Unity.
Why don't we dive into that real quick and then go back to design patterns after? Because I think it's an interesting thing, and it's something where I'm going to learn a lot because I'm still not great with these play mode tests.
Yeah. So basically, eventually you're gonna need to have a mono behavior. And if you think of what a mono behavior is, it's a component of a game object, and you have to think about it like that because it can't exist in any other way in Unity. A mono behavior has to be attached to a game object, and it has to be managed by Unity's ecosystem. So when you press play, your mono behaviors are attached to a game object. That's the only way you're ever going to get it to run. And the same thing applies to when you're running a test. So if I want to test a mono behavior, I have to create a new game object in memory, add my mono behavior, and then at that point, I could test what it's doing what I want it to do. Now, if you're just getting into unit testing, you're going to see a lot of example code with what's called a pure function. A pure function is a function that takes an input and has an output, and that's easy to test. It's very easy to test. You give it input, you assert that you expect what you expected came out. With a mono behavior, a lot of your code is going to exist in an update method. An update method has no output and it doesn't have any input. So all you could really do is expose some state in a public method or a public property, do a couple updates that Unity will run, and then test that state to see if it worked. Now, let's give an example of that. So what is a public property of a mono behavior? Well, a game object is like the transform, the position. So let's say, for instance, you have a mono behavior and it's like a bullet. Maybe it's the bullet mono behavior, and all it does is propel a game object forward. So what you would do is you'd create this mono behavior in your test, and you'd attach it to a game object, and then you would allow the update method to be triggered. And you do that. I don't want to get too low level, but basically with a play mode test, you have to have it return an I enumerator. And then when you do a yield, you say yield wait for frame or wait for update or wait for seconds. You can do any number of these types of waits. And what that does is it lets Unity run. It lets the update loop run. So the idea is while that update loop is running, all the things that you expect to happen in your scene when you press play in your Unity editor, they're all happening right there in memory in your tests, you know? And then you can test, you can, for instance, with the bullet example, you can test the position of your game object after you let it run for a couple seconds and see that it's moved. And if it has, you can say, oh, I assert that passed or not. And that's really what play mode tests help you do. They help you test model behaviors in the Unity ecosystem. All those dependencies that come with pressing play, you get in a play mode test.
Okay. I mean, they don't sound too bad, but how hard are they to set up compared to unit tests?
They're not difficult, but they're slow. The idea behind unit tests is that you want them to run real fast. It should never be a burden to run a test. That's kind of one of the things with unit testing too, is that you need them to run fast. Like for instance, when I'm developing in pure.NET, not Unity, if I'm developing like an ASP.NET or like some sort of web application or something, my test runner is running continuously. Meaning as I'm writing code, every time I stop writing, the test runs. My whole test suite runs. Or I have it configurable so you can configure it so if I'm working on a particular method, the tests for that method will run. But the idea is that they're happening all the time. I'm getting immediate feedback if I ever break anything. And I know exactly what I broke. But with play mode tests, it's like think of having to go into Unity and press play. I mean, every time you press play, you lose at least 2 or 3 seconds waiting for the thing to boot up and your whole scene to get started. That's basically what it costs. So I think that with play mode tests, I tend to treat those more like integration tests, and I might test like a whole behavior, a whole interaction in that. So, you know, if you ever see the automation test pyramid, you'll have unit tests on the bottom, and that means most of your tests will be unit tests because they're fast. But then in the middle, you'll have integration tests. Integration tests are any tests that test the functionality of 2 or more objects that work together, depend on each other. Those are slower. And at the highest level, you'll have your functional or system tests, and those will literally be running through like an actual the interactions of user clicking on the screen. And there's a couple tools for that. Not really many for Unity, but actually none for Unity that I know of. But basically, at that high level, you're only going to have like maybe 10 or 20, depending on the size of the applications, of these highest level system tests, and they take a long time to run. You know what I mean? They can take
a lot
minutes.
of the time they're manual.
A lot of the time they're manual. Yeah, you typically would have a hybrid of that. You'd have some scripts that you would have the interns run or something, or maybe if you run them, and then you'd have like some scripted ones. Like if anyone's ever done web development, you might use Gauge or Selenium to run those, and those will literally, like Selenium literally opens up Chrome or Firefox and we'll click the links and we'll test. Was this button here? Was the title of the web page what you expected it to be? The cart, did the cart get filled with the items you wanted? So those are high level tests that take a long time to run. But in the middle is where you'll have play tests, and those play mode tests typically take a long time to run. You don't really want to depend on those a lot.
Okay, yeah, that sounds right to me. Like I'll have to try out some more of the play mode tests though. Like I said, I haven't done a whole lot of them, but the unit tests, all into them, and they're nice and fast. Like you said, it's super quick. It's 2 seconds to run all my tests. And I know where I run my tests from. I'm curious, where do you run your unit tests? So you've written the tests, everything you think is working. How do you run it to know whether or not it's working? How do you get it to go red or go green?
Well, if I'm doing pure Unity, I'll run them in the test runner in Unity.
Okay.
I use Writer as my main IDE, and they're talking about having play mode tests added to Writer, so being supported by Writer, so you can run them right in the IDE. That's where I'd prefer to run them. But depending on the sophistication of the project, a lot of the times I'll take a lot of any C# code, any .NET code that I can have not depend on Unity. I can have it live in a vacuum. I'll drop it in its own project as a DLL.
Oh, okay.
So I like, if you look at I'm working on a framework right now for Unity, and most of the code is just in another library. It's a pure .NET library.
Yeah, I've known a couple of people who've done that for primarily for the reason of forcing separation of concerns and keeping their game logic separated from Unity. Because it does totally force you to do that. You don't have a choice.
Oh yeah, yeah. You don't have a choice.
You can't accidentally intermingle them. Cool. Do you run your just regular unit tests out of Writer?
Yeah, definitely. I'll have continuous testing turned on. Like at work, I'll have that turned on. So as I'm developing something, it's testing as I write.
Oh, okay. I wonder if that works for the Unity unit tests in there. I know I can run them in Writer, but I've never tried the continuous. It seems like it would be a problem.
I can definitively say no, because if you watch the company that created Writer, JetBrains, they did a talk at Unite in LA. And if you go all the way to the end of the video, you'll hear someone ask a question asking, hey, are you planning to support continuous testing? And they say no, and that's me.
Oh, does not support it. Okay.
I actually commented on the video. So if you go to the video, you'll probably see my comment saying, hey, that's me. And I put a timestamp to the.
Nice.
But I asked them and they said no. So I was like, all right, well.
Okay. Fair enough. Well, the tests do run on build, at least. Yeah.
I haven't been able to get them to work for me.
Oh, okay. We got a build process set up that's doing it. So.
Oh, nice.
Because you can kick them off with a command line process. So it just runs the command line, and then you get back a fail. If it's like a non-zero result as a fail, I think the standard, and then it writes out all the results to an XML file.
That's smart.
So
I never. Shit, I'm gonna do a video on that.
Oh yeah. Yeah. It's a cool subject. It's nice to have that so that when you commit, a build happens automatically through your continuous build, continuous integration system, and then the tests are run and kind of get some notification on a failure immediately. I mean, ideally, you should be running the tests before you commit the code, obviously. But everybody forgets. I forget. I think everybody kind of forgets. So it's good to do.
Integration will be a fail safe. Won't let it get out to production.
Yeah, and you can even I haven't done it yet, but I know you can set up Git hooks to force the tests to run before the commit even goes through, so that it does the whole process. I just don't quite know how to set it up, and haven't had the time to try.
And you're giving me some good video ideas.
Yeah, these are great things that I would love to see a nice step-by-step on how to do. Like just like about to commits rejected because I failed my unit tests. Yeah, so I guess I kind of want to dive back into the design pattern stuff a little bit. You talked a little bit about the humble object stuff, which I think is super important. The whole idea of do you want to just recap what it was again?
Oh yeah, right. So we talked about play mode tests, and that's for testing mono behaviors. But sometimes you really just want to have something you can have as a regular unit test that it's just C# code. And this actually works if you're separating your project into separate DLLs and you have like a pure .NET DLL or project. In that case, you could basically take all the logic within the mono behavior and encapsulate it into a class, and that class can be a pure C# class. So for example,
you can do this without going into a separate DLL too, though.
Yeah, you can. Absolutely.
Just to make sure they're not confused. But yeah,
for sure. I just like to do that because in Writer, I get more functionality if it's not a Unity-based thing.
Oh yeah, and you have that enforced. You can't make a mistake, right? You can't accidentally use unity stuff. But sorry to interrupt. Go ahead.
No worries. No, that was a good point, though. I don't want people to be confused about that. So basically, so for instance, how about a movement behavior? So let's say you have player movement mono behavior. And in there, you check vertical and horizontal input. And based on that, you have a vector. And you take that vector and you apply that to the transform. Well, one thing you could do is you can just encapsulate some of that logic. For instance, the input logic is not testable. I mean, I can talk about how you can encapsulate input later. I actually did a whole video on that. But basically, you don't want to test input. You can't test input, at least not literal input. So what you do is you take the values that you expect to come off of input and what you would do with those values, and you can just wrap those up into a method. And then furthermore, you can wrap that whole method up into a class. And all you do is take that class and test it separately, call it maybe the movement class. And all it would really do is maybe you could have a pure function where it just takes a vector 2, which would be horizontal and vertical, and then it just outputs another vector 2 that is the result of you moving. Or another thing you could do is you could pass in the transform just as a reference inside of that class, and it could go ahead and just do the application of the movement to the transform. But there's a couple ways to go about it. But the main high-level idea of the humble object pattern is you're encapsulating all of the logic into testable chunks that get put into their own class. So.
Right, so you're just kind of wrapping all of the logic that's in the mono behavior that's not part of Unity, that's not like the update loop, the code that's actually functioning, and they're like, you have a weapon and it fires. Everything other than instantiate the prefab and add force to the rigid body can be in another class, basically, and then that can just call back into the mono behavior to say, hey, oh yeah, add this force and spawn this thing. But then all of the rest of the logic, like, do I have the ammo? Is this thing in range? Is it the right kind of target? Maybe it's not just like point and shoot, but it's a NPC shooting another, like a tank shooting a tank, right? Like all of that targeting logic, all of that kind of stuff, you can easily have. You don't need Unity and you don't need mono behaviors for it. So you can start to separate that out. And I think that's like going even beyond the humble object pattern, just into a clear separation of concerns on the code can make a big difference. Just trying to follow single responsibility principle where just each class does one thing, at least for the most part, always exceptions, but in general, trying to follow that and trying to keep everything really separated, I think helps a lot with that. If you don't have big monolithic classes, it helps a lot. It makes it a lot easier to test. You can test the small things, like if you have a jumper class, you can easily test all of the functionality in that jumper class and have it be totally independent of whatever the other classes are on your character. And you may not want to do that for the specific character. Like you might have like a tank class, right? Or a helicopter class or something like that. It may not get too granular, but then on your helicopter class, you'd probably have separate weapons. You'd have a weapon class that holds some weapons and then fires the weapons or whatever. Or there's some weapon struct data there that's holding the data about the weapons, and a whole nother system where you pass in the weapons and get the result that you expect, right?
Exactly.
I feel like this works a lot better with a visual example, though.
Of course.
I can think of a couple.
Good example.
Like I'll just give an example I've actually done recently, which was with MMO targeting stuff. So just got an ability system where you're a wizard or whatever, and you're casting an AoE spell that like targets a guy and then spreads off of him and does damage to everything around them. So that's a system that I had to get under test. And it's not just that, but like it could be a single target spell. It could target 3 things. It could target and heal or whatever, right? So the way I did that was like basically breaking it into a bunch of individual functional steps and then being able to unit test those steps. Like step 1, find all of the possible targets. Because then I can unit test. I can say, hey, call this method, or like here are all the things in the test at the beginning of the setup. I'll say, hey, create these 3 NPCs, add them to the cell graph, which is basically essentially like a list of the NPCs there. Right? There's some extra data for range and all that, but essentially add them to the list of NPCs alive, and then call this targeting method, and it should get all of these things that are all of these NPCs. Right? Super simple test, because it's just like, hey, call this method. I should get all those. But then the next step is like, check to see that they're valid targets. So then I pass in that same set of data, and then I should get back out. Like say I've set it up so that NPC 1 is like invulnerable, so he's not valid. NPC 2 is valid, and NPC 3 is valid. I should be able to set up that list, pass that into the method of, hey, give me the valid ones, and then get back a result that says, hey, these are the 2 valid ones. Because then I can start to test all of those different behaviors. I can test that it's because they're invulnerable, they're no longer valid, or because they're too far away, they're out of range, and I get they're marked as out of range and no longer in the list, or whatever it is. And basically I have a big list of those, and it makes the entire system very easy to both understand, because you can see the entire flow just step by step, like here's what happens with the data, and you can see the tests for it, so you can tell exactly what step broke. Like I know why like if an ability doesn't hit the third target, I know why, right? Like it's because it failed in this chunk of code because that's the test that's failing. It tells me. So
that's one of the great side effects of tests too. And people have many opinions about this, but your test suite as a whole can test as a source of documentation. In fact, I know it. I did this a lot with the ECS, Unity ECS. When I come across a new framework or an API or something that I'm trying to learn, and then maybe the documentation isn't all up to snuff, like the Unity ECS's documentation, I go straight to the unit tests. And you can tell by reading what the tests are called, and you can honestly tell how to use something by looking at how they're used in the test, because that's really all unit tests are exercising your code. And so I know that I was trying to figure out early on in Unity ECS, I was trying to understand how the mesh renderer system worked. And the documentation wasn't there. Maybe some people were talking about it on the forum, but I just wasn't getting it. And I just went to the test. There was a mesh instance renderer system tests. Saw how they used it. I saw exactly what components they added to the entities that they expected to be there. And I saw which tests checked to make sure that something was actually being rendered. And I just copied that and taught me how to do it.
Yeah, that's great. I think that's an amazing use case for it too. If for that to work, the tests, of course, have to be well named.
Yeah.
But other than that, yeah, it's great because you can see.
And even if they're not, you can glean them. You can at least, if you could at least get an idea of how the people who wrote the code expect it to be used, in your client, then you can at least have a pretty well-educated guess of how to use it yourself.
Yeah, that makes sense. Yeah, I guess you just start searching for references for the things that you're interested in, and then start looking through those tests.
Granted, you want to name your tests well, but
ideally,
it's hard. Let me tell you, it's very hard.
Naming tests is not an easy task for sure.
I've had some long tests where I'm just like, this is ridiculous.
Yeah, that's definitely the case. And I think I mentioned before we started that recently I started doing some more behavior-driven development after watching a video. I'll link that video too. So it was, I thought, really good. But I found that the naming structure there has really worked for me. And it was like, you know what I should do is just pull an actual test.
Okay, that's good. Yeah.
Like I think I should have some open here, but the tests were like a thing. When a thing happens, I expect this to happen. So let's see, where are my unit tests?
Like I have this whole list of them. I should send it to you, but it's like one of them is given preconditions, when state under test, then expected behavior. That's like the behavior driven development like template for naming tests.
Yeah, and that's very much like what these look like. If I could ever find them, I'm terrible at finding tests. I forgot because I named them with a totally different naming scheme, and they just don't seem to be showing up.
I recommend anyone listening who's interested in learning how to name tests. There's a great article on dzone.com. Just Google 7 popular unit test naming conventions, and they have 7 conventions, and they explain each one, and they're all really valid. They're all good. I've used them all.
Which one do you use now? Like, what is your standard naming right now if you were naming a test?
I typically just say when, and then some state under test, like maybe when positive horizontal input, then, and then I put the expected behavior. Then player moves left or right.
Oh, okay. So that sounds very much like very similar to what I've been switching to or recently switched to. Yeah, it's just the which I'll never find these tests. They're lost forever.
Another, I guess. So the first one that I mentioned, the given, when, and then, it actually matches acceptance criteria. So I typically would use that one when they're like, at work, we do Scrum pretty heavily, and we make sure that every ticket has acceptance criteria. And acceptance criteria is a statement that basically says, given this condition, when this thing happens, then what you expect. And there is an actual test naming convention that matches that. So if I'm doing a ticket, I'm working to a ticket, and I need to have acceptance criteria, I'll actually name my test in that way. But my other tests that are less sophisticated or maybe less strict, I guess, I'll pretty much dumb them down and make them a little simpler.
Oh, okay.
Another thing I'll say is what's important about how you name your tests isn't necessarily how they look in your code. Because sometimes I've had tests that just look really ugly, in my IDE. What's really important is how they look in your reports and in your test runner. Because when you're going to be reading those names, it's going to be when your continuous integration catches a failure or when your test runner catches a failure. And you're not necessarily going to be looking at your code, and you're not necessarily going to have your IDE open. What you're going to be looking at is an email from your continuous integration system emailing you saying, this test broke. And generally, it's going to say the exact test name. And that's what you're going to want to make sure looks legible to you. And that's how you should write your tests.
Yeah, that I totally agree. And I failed at that at first. I used to write extremely long test names and short class names. Like I'd have ability tests and then a paragraph, which like that second or third step in naming where it's just terrible. And then I ran into the same problem. Like I can't really tell what all these tests are in the test runner because they look the same. They all start with like the same 3 words and then a little bit different on the end. So I finally did find one of these tests, and the new schema, the way that I've done it now is the namespace is tests, and then it's actually tests.buffController for this one. Then the class is with no buffs, and the one test on it right now is not ready to tick. So it just says that a buff controller with no buffs is not ready to tick. So it's kind of weird because the class name has absolutely nothing to do with it. It's just the namespace. The namespace is essentially telling me what class I'm testing.
Yeah.
But then in my test runner, like if everybody could see this, it looks really nice because then I see buff controller, I expand out, I see, with no buffs, expand out is not ready to tick. And it's very simple and easy to read in that test runner. Like I said, I've only been doing that for about a week. So that's a tiny portion of my tests, but when I compare it, when I read to the other ones, it's just night and day. It's like I like reading these.
So, all right, to give you a little advice on naming your test, you said that you use namespaces to be the name of your class under test.
Yeah.
What I do is I'll nest classes. So let's say I'm testing the player class. I'll have a top level class, call it player tests. And then inside of that, I'll nest another class that's the method I'm testing. So let's say I have player move. So I have player, and nested within player tests, I have move tests. And nested within move tests, I have just all my tests. So basically, for instance, what I had said before, if horizontal input positive, then move left. And so I'd have player nested within move, nested within that test. And it really is much easier to read in the test runner. In fact, I'll send you an article. Maybe you can link it in the description of this video where I got that from. Like that is honestly, I forgot about it, is my favorite way to organize my tests.
I love it. Yeah, that sounds
awesome.
Better than what I had. So I just wanted to awesome new tip. That's great. Thank you.
Yeah, no problem.
That's good advice. So
glad to talk to someone else who's interested in testing, because it's a very it's a touchy subject sometimes, especially test-driven development. I've heard people just say that it's a complete waste of time. Why would you write more code? It's like you're writing double code. And, on the surface, a lot of arguments that people make seem very valid. But man, I've worked on enterprise applications for 6 years, and I've worked on, I worked for the city of Miami. I worked on applications for the police department and the fire department. And I know that I know that games aren't, going to kill anyone if they fail. But at the end of the day, software is software, and you can treat it like a craft, and you can do it right with minimal effort. You just have to put the upfront work to understand it, even a little bit. And that upfront work honestly pays huge dividends that people don't even realize, because people will say, a lot of developers I've heard say, oh, it's a small project. Oh, it's just a prototype. It's just this. But honestly, if it were ever going to be anything, you would have wanted to do the tests up front, because once you don't do them, you will never do them.
Yeah, it's a tough thing. Like, getting people past that point of thinking that it's a waste of time, it has probably been the hardest thing to do. But once you actually start to see the benefit and the value, and I think part of it is that it does seem like you're writing twice as much code, but you're really not. Like, you're maybe typing 2 or 3 times as much, but there's no cognitive load there on your test, right? If you have to think through what your test is doing and it's really hard, and you're already a little bit familiar with the framework, then you're doing something wrong. Like, your test is way too complicated. The test should be really simple to write, and all of the thinking and hard stuff should be the actual code that hooks into the tests are calling. So it's not like, it seems like you're writing a lot more, but you're really not. It's really just kind of, you're adding some almost boilerplatey code to make sure that your other stuff works. And you're getting, like you said, you're spending a bit of extra time and a bit of extra work up front, but the payoff comes, I guess it's not immediate, right? The payoff is short or small at the beginning. Like, it's just hey, this thing worked and it's still good and it didn't break next week or whatever. The long-term benefits that you get, I think, are a lot bigger. Like, with these ability tests that I've mentioned, I've refactored this entire system twice, like complete refactors, changed whole giant chunks of functionality, but I'm relatively confident every time that everything is good because the stuff is under test. And every time I refactor, I put more and more stuff under test. It's mostly refactoring so that the parts that aren't under test can get there. But it's also making the code dramatically easier to understand, easier to read, which means it's easier for me when I need to go fix a bug or add a feature. And it's easier for everybody else on the team who needs to go look at something or interact with systems. They can see it, like you mentioned, with looking at the test. They can see exactly how you're supposed to work with this thing.
Especially if you have other developers in the project and, you don't have the time to explain every little bit of code. I've gotten into the habit of looking at tests, and you understand pretty easily what's going on.
Yeah. There was one other thing I wanted to talk about before we wrap up too, which was just the idea of mocks and substitutes.
Yeah.
So
I have a video on that too.
One of my favorite things is end substitute now.
Oh yeah, it's great.
Just creating mocks for the things that would be mono behavior. So, like, a lot of the time I have instances where I've got a class that's a mono behavior, and that's not the thing I'm testing, but the thing I'm testing relies on that, and I need to make that work. So I know kind of my system for that. Do you have something like that you recommend for people to do with that? Like, they've got a player, the player's a mono behavior, they can't change it. It's stuck that way, and they need to test like a trap script that is supposed to kill players.
Yeah, I mean, end substitute's great for substituting things like mono behaviors or logic. Like, for instance, input is a great example of something that's very hard to test. And my advice there is encapsulate everything you can, within reason, of course. And what I mean by that is something like input. If you rely on the Unity's static input class. Static classes are one of the biggest killers of tests. You have a static class, you have no control over that, unless you have some sort of way to override the instance, if you're doing some sort of like static.instance.
I have one of those, and I literally have a check in there to see if I'm in a test, because I almost have to, because it's code I can't change.
Yeah. So things like that, I would say encapsulate it. So for the Unity, I've done this a million times. Unity input dot get access. I encapsulate that into an interface. So I would call it I input service, and then I would implement I input service as Unity input service, or Unity input or whatever, and I would expose a public method called get access that returns a float. And accepts a string. And
so you pass in like horizontal and get your 0 to 1 or -1 to 1, right?
Yeah, exactly. So with that in my test, if I have any bit of code that depends on input, I could simply say, I'm just going to create a mock of I interface and give it to my mono behavior. And if people don't know what a mock is, there's actually different types of, there's mocks, stubs. Gosh, I forget what the other ones are, but they have different sort of use cases. I'm going to get it wrong. I'm going to go read this later and be like, crap, I got it wrong. But a mock, I think, is specifically a type that you can give it a return value. You can say, I'm going to fake it that I have an actual input service, but I really don't. It's just my fake one. And I'm going to say whenever some code calls get access and passes in the string horizontal, I'm going to force it to return the value 1. And in that, you can include that in your test, and you know that every time that test run, that mock is going to return 1 for get access horizontal. And that way you have full control over what your test is doing. And if it returns something that you don't expect, you can assert that and you can make it fail with, confidence.
Yeah, and that's exactly the way I do it too. It's really cool being able to do that with Unity and substitute. It's just a simple call to, you do substitute.for, give it that interface, and then you get that object back that's a mock of the interface. And then you just go to the properties. So anybody trying to do this at home, if you like get access, you'd do like the input system.getAccess.returns and then put in a 1, and then it will return back a 1. Yeah. Which is really cool. You can also do some nice stuff in there to assert for things being called. There's a lot of cool unit stuff tests. I highly recommend you just kind of go through Charles' videos and check them all out and learn this stuff in depth, because it's really cool, and it'll make a big difference on your projects. I think it does for me. Like I said, if you're doing a project that lasts for more than a couple months, or there are multiple people working on it, or you actually plan to ship it, you should try to test it. Yeah, I mean, ideally you should have it tested.
Yeah, I mean, doing it on any project is just good practice. It's a good habit to get into. And honestly, if you've never done it before, I'm going to tell you this. If you've never done unit testing before and you're going to try to do it on a project, don't do it on a project you're working on. Like, let's say it's for work or something, because you are going to lose a lot of productivity. It's going to suck. It's going to be hard. And honestly, my best advice is you're just going to need to practice, because those first couple months of doing it, all you can really do is copy what you learn in tutorials and read books and copy what you learn in books. I was trying to look this up earlier. There's like the Dreifer levels of knowledge. I forget what it is, but basically when you're first learning it, just don't try to get cute with it. Don't try to do anything sophisticated. Don't try to customize it in any way. Just try to learn the basic process of writing tests and even test-driven development, because that's a great way to get into it. And just follow the steps. Because eventually you'll either decide that you get it and you can move forward with that, or you're going to get to a point where maybe you decide it's not for you. And if that's the case, that's all you can do. But I think where a lot of people get really hung up is that in those first couple months of learning it, they try to go too fast and too complicated too quickly, and it becomes very overwhelming. And also, I would say, don't try to do testing on a project that you're trying to get out the door and you're actually working on. Do it on just those side projects. Do little tests, and don't try to get too sophisticated. Just follow tutorials and just try to get the idea of it first before you try to get too sophisticated.
Yeah, definitely, and do some code katas too. The code katas for Unity.
Yeah, for sure.
Great, because you can write the tests and you can write the code around it, and it just kind of you get it used to it, get into the flow of it, and then once it clicks, which is still relatively recent for me, it makes a big difference. You'll see it and you'll love it.
Yeah, it's definitely worth it. I mean, I've actually I've known some developers to honestly do their due diligence, and for whatever reason, they're just functional programmers at heart. They just don't want to do it and never clicks with them. But I'm telling you, it really does make a difference. I think that most developers should really invest in this skill.
Yeah, I totally agree. Well, Charles, anything else you want to talk about before we wrap this up?
I don't know. This was fun. Check out my YouTube channel. And, I really enjoy being a part of the community. Been doing this for a little over over a year and a half now, I think. And in this time, I've met people like you and plenty of other, YouTubers and people who are just creating. And, that's really what I've become passionate about. I'm passionate about software development and game development, but, really what I'm passionate about is creating and craftsmanship, which I think is why I like unit testing so much. I really enjoy being a part of a creative community that, is creative both artistically and, logically, when it comes to software development. And, it's just been a real honor to take part in this. And it's really, really great. I'm excited to see, what happens in 2019 and how it expands, because I know it will.
Oh yeah. It's just getting better, man. And I agree with you on the creativity part and the software craftsmanship 100%, because my artistic skill sucks, but I feel like I get the same excitement and enjoyment out of like some nice, cleanly crafted, really functional, really good code. Right? Like I look at it like, that is beautiful code. Not like the art. Nobody's ever going to see it and tell me it was beautiful, but
I love looking over some real nice, well-written code. Real decoupled, encapsulated, solid.
Yeah, I'm with you. I like the same thing. So cool. All right. Well, thanks again, man. I really appreciate having you on here. We'll have to talk again sometime soon.
Absolutely. Thank you, man. Appreciate it.